Hi everyone. Today we're going to use what we talked about with graphing from standard form to convert our standard form of a quadratic equation into vertex form, which we talked about. So it's really not going to be anything new. We're just going to apply to what we learned in example 1 and 2 and finding the vertex point to writing standard form into vertex form. Okay, let's get started. Let's see. Here we go. Okay, so example 3, we're going to be starting from the standard form of a quadratic equation, and we will be transforming that equation into vertex form, which we talked about before. It's y equals a times x minus h squared plus k, which remember, vertex form is really helpful when you have to graph a parabola because it's really easy to find the vertex point. So later on, you guys will learn how to graph a parabola from vertex form. But it's nice to know if you start from standard form, this is another way you can get to vertex form. Now, technically, we have talked about already that you can complete the square to get from standard form to vertex form. So technically, you still can complete the square. I'm just going to show you another way that you can get from standard form into vertex form using what we learned in example 1 and 2. So again, if you don't like this way, you can still technically complete the square. In my opinion, though, this technique is a lot easier than completing the square, but, it's kind of up to you. Okay, well, let's get started. So when we have standard form, which is y equals ax squared plus bx plus c, okay, the a value in standard form is actually the same a value that you find in vertex form. So if I identify the a value in standard form, guess what? You have the a value in vertex form. Holy hot dog, right? I know. Okay, so the a value is the number in front of the x squared, which remember, if you don't see a number in front of the x squared, which currently I don't see one, remember there's a secret little ninja in front of it called 1. Okay, so 1 is hiding out in front of the x squared if you don't see a number in front of it. So my a value is 1, which means in vertex form, the a value is also going to be 1. Okay, so in vertex form, all you need to make vertex form, you need the a value, and then you need the h and k value, which come from the vertex point. Okay, you are going to leave the y and x as y and x. Don't touch the y and x. Leave those bad boys alone. Okay, so I'm just going to fill in the values for the a, the h, and k, which guess what? We already know a. A is 1. There we go. It's the same a value as what you have in standard form. Okay, so now in standard form, if you recall from example 1 and 2, to find the vertex point, first of all, remember the axis of symmetry equation finds the x value of the vertex point, which is technically the h value because the h value is sitting in the first spot of your point, which is technically the x value. Okay, so if I find the axis of symmetry, I will know the h value. Don't forget though, remember we have to switch the signs from our vertex point to our vertex form, so keep that in mind. You have to think the opposite with h. And then your k value, after we know what x is, then we're going to substitute x into our original equation to find the y value of your vertex point, which is technically the k value. Okay? All right, well, let's find the axis of symmetry. So the axis of symmetry equation is negative b, or the opposite of b. What is the opposite of my b value? Correctamundo. That would be a negative 6. Nice job, you guys. You guys are so smart. You should teach me what to do, not the other way around. And then over 2 times a, which a is 1. All right, let's solve this thing. So we have negative 6 over 2 times 1, which is 2. And then negative 6 divided by 2 is negative 3. Okay, so the h value of my vertex point is negative 3. All right, so my vertex point, let's see here. I didn't really make a spot for the vertex point, so I'm just going to do it right here. Our vertex point, the h value we know is negative 3. And I'm just going to double check everything real quickly. Yep, negative 3. Okay, and then now we need to find the k value. So remember the way we do that, if you remember in example 1 and 2, I'm going to substitute -3 in for every single x in my equation, and bam, that will give me the k value, which is the y coordinate of my vertex point. Okay, so all my x's will be transforming into a -3. Okay, so I have y equals, technically a is 1, so you don't have to list it. So it's going to be my x squared will turn into -3. So it'll be -3 squared, and then plus 6 times -3. 6 times x, so x has transformed into a -3, and then plus 9. All right, let's solve for y. Okay, so -3 squared, -3 times -3 is 9. 6 times -3 is -18 plus 9. Okay, so 9 minus 18 is -9, and -9 plus 9, well, that's 0. Okay, so the k value is going to be 0. Okay, so I have my h and my k now, so I have my h value and my k value. All right, so now I just need to fill them into my equation, and then guess what? We have vertex form. So don't forget, you guys, for the h value, you have to flip the sign on the h. So the opposite of -3 would be +3, so it'd be +3. And then k, so technically k is 0, so you could put +0 on the end, but whenever you add 0 to a number, it doesn't really change it. So I could technically rewrite this as y equals, technically you also don't have to list the 1 in front because 1 times anything is also itself. So I'm going to list it just to keep it there, but you don't have to. So then we have x plus 3. And then I'm not going to list the 0 because if you add 0 to anything, it doesn't change it. So guess what, you guys? This is vertex form. Fun times.